For that, let me take you how a typical deep learning program works. Right? We have discussed there are three things required for any machine learning: input, answers, and optimization function. How do I know that? What is the optimization? How do I know the error value, or how do I know that the model is good? Right? Those are the three questions we need to ask. These are the three inputs. So now a typical deep learning model, how does it work? I have shown you the transformations and the layers. How actually the training happens, right? How actually the training happens is what we'll see now through a diagram. So first, we will now try to think of a simple example, right? I will start with a very simple example, something like y is equal to ax1 plus bx2 plus cx3. Simple. So y is I want y as the output. A, B, C are some constants, and x1, x2, x3 are my inputs. Let's say it's a 3D coordinate system, right? x1, x2, x3 are or any three parameters, right? I don't want to call it as 3D; it will confuse, right? So let's say there are three parameters: x1, x2, and x3, and there are three constants: A, B, and C, and the actual formula is y is equal to ax1 plus bx2 plus cx3. So in this case, if I have enough x1, x2, x3, right? If I have this formula, then not a problem, right? I know that any x1, x2, x3, I can easily calculate y. But the whole idea is machine learning doesn't know this formula. It is supposed to come with this formula, right? We know, but what we know is we know some values of x1, x2, x3. We know some values of y. So for every set, for some sets of x1, x2, x3, we know what is the corresponding y. This is what we know, right? Now, if you look at the problem, I'm giving the formula just for you to understand, right? Now, actually, we don't have the formula. So for us to understand, if ax1 plus bx2 plus cx3 is there, if we have for every x1, x2, x3, we have a y, then we have to calculate ABC. All we need is ABC, right? So we are calling these ABC as weights, meaning whatever input parameters they are having some weightage we are applying for that to be transformed into the next transformation, whatever it is, right? So that weightage, I'm calling it as weights. So let's take a simple multi-layered deep learning model. I'm just given example of 2 layers, right? In the 2 layers, they have some weights. So now I have input from one direction, I have weights from other direction, right? So that layer has a data transformation. It will transform the inputs based on the weights. But the problem is I don't know the weights. That's the weights are what I need to find out. But what I will do, like any other mathematical problem, which uses this methods of optimization, I will start with some weights. I will say I will start with some default weights. Right? I will say, okay, I will assume that, let's say these are the weights. And for the given input, I will do the data transformation, right? Because now I have 2 things. I have input, I have the answers, right? I have assumed some weights, 3 things I have done. Now let's see. So now what will happen? I will pass through this data transformation, my input x, based on my assumed weights, right? Then I will get y, true, right? So I'm using this to train, meaning in my training data, I have the input, I have the answers. I'm now passing my input through the layers and given some weights which I have assumed and started with, right? And then obviously I will get a prediction because rules are there. Rules are basically weights. I have assumed something and the transformation I have done and input is there. It gets transformed based on the weights to the prediction. Now I have the true answers also. For every input x, because this is a training data, I have the true answers. So what I will do is I have predicted something based on these weights, which I'm still trying to find out. Based on these weights, I have predicted something. I have the true answer. And I know the function we spoke, right? We need input, we need answers, true targets, and we also need a function to calculate how well my model is working. So that function in technical terms is called loss function, right? So thus loss function is used to calculate the how good the model is. Meaning right now the model is predicting y and the actual is, let's say, y prime. So the loss function could be, let's say, log y prime by y. Right? In that case, we are saying that if y prime is equal to y, then there is no error, right? But if there is no loss. But if there is some difference, then we are saying there is some loss. I just gave an example of logarithmic loss function. The function could be anything, right? So we have developed a function saying that this is how I will validate if the prediction is correct or not, how much of error I can bear. I have given that. Now I have got the true targets. I have got some predictions. I've calculated my loss based on the predictions that I have done on the assumed weights or the initial weights, and true targets answers are from the training data. Right? I created a score. Obviously, I have calculated loss function. I got the score. Now, this score will go into a engine, which is the most important thing in the machine learning world. This comes in the mathematical framework we discussed about. This optimizer is the one which looks at the loss score, and based on some techniques which are mathematical again, are like gradient technique and all, they will adjust these weights so that the loss is minimized. Meaning they will now adjust the weights. Let's say ABC are weights. So A, let's say we started with 0, 0, 0, or let's say I started with 0.1, 0.1, 0.1. Now, based on the loss score, right, it can create some tangents because it has some data based on which it has predicted, right? So it has the data, it has some plotting. Based on that, it can create some tangents and then find out where the loss function is, where is the loss function maximizing, or if you want to minimize the loss function, towards which direction we should move to minimize the loss function. Because it has a loss function, it has the weights, it can now predict which is the next best weight to try on, so that I am moving towards the maximum of the loss function or minimum of the loss function. I want to minimize, right? I want to go to the minimum of the loss function, right? Loss function in a 2D case, it's simple function, right? There is a minima which can go, or in case of 3D function, it could be a a whole kind of thing. So all these things are possible. Now the weights are optimized so that we are moving towards it. We don't suddenly move, we move in small bits. We go to the next weights based on that. Okay, now I'm seeing that the slope of this is here and I want to go to minimum. So I have to move towards the slope of the line. So I move little towards the slope. The weights are now moved towards the slope. Now I came little closer to that, right? And then I will again do the same input layer data transform. I will again calculate the loss score. Now I will see, have I reached the expected optimization. If not, right, I will optimize again, right? So optimizer will keep changing the weights. Again, little weight will be changed. We'll do again transformation. We will keep moving towards the minima, right? And whenever, if you have crossed the minima by some reason, then we know that now we have to come back. So we'll come back with a lesser quantity. So we somehow, keep going ahead, come back, and we equilibrium, reach the point where the sweet spot is there, where the loss function has been optimized, right? So this is the framework, what happens behind any of the deep learning with multiple layers, right? The optimizers keep changing. There can be multiple optimizers available. We can write our own optimizers, or there are multiple loss functions are available. We can write our own loss functions, right? The weights, we can give the initial values where we want to start if we have a good prediction. Input and the two targets are the training data. They come from the training data.